All right, students, we are back. Hi, now you can see me. Actually, we're somewhere around here. That's a joke. For Callie, since you can't see the cartoon, today's cartoon is a normal distribution with a you are here in the kind of bottom 5% of the normal distribution and a homeless drunk person sitting on the ground kind of staring up at the poster looking unhappy. Anyway, we are going to continue our work on the normal distribution, and just as a quick review, last time we looked at areas under the curve. For example, this problem, find the area under the standard normal curve to the left of z equals negative 0.99, and we were able to use our standard normal table and determine that that should be 0.1611. Our next problem was to look at the right of a z-score of 1.06, and we were able to use the complement rule and the standard normal table. First, we found the probability to the left of that number, and then we took 1 minus that probability to find the probability to the right of that number. And then finally, we looked at the probability between two values, specifically z equals negative 1.5 and z equals 1.25. And we went and found two values, two cumulative probabilities in our standard normal table. We found the one that goes all the way up to 1.25, and that was 0.8944. We found the one that goes up to negative 1.50, and that was 0.0668. And then we took the difference of the two to find the probability in that specific range between negative 1.5 and 1.25. So that's where we landed at the end of the last set of lectures. We're now going to make sure that we understand that all of these areas under the curve are just probabilities. And what we're going to do now is talk about doing some word problems related to probability and normal distributions. And we can go back and use the standard normal table to find those probabilities. We're also going to start introducing through the lab some software, specifically Excel, and we're going to be able to look up some of these probabilities using a single command in Excel called normdist. So we will do that as we continue through this set of lecture slides. So the picture here, we're on slide 5, Callie, and the picture here is the probability x less than 600, and it's showing how that probability, again, is just a cumulative probability up to x equal to 600. However, in this case, it's a normal distribution with mu equals 500 and sigma equals 100. So we're going to have to do a transformation, get a z-score, and find the probability for the equivalent z-score. So how are we going to do that? Well, we're starting with our normal distribution with mu equals 500 and sigma equals 100. And then we're going to take x minus mu over sigma. So that's going to be x minus 500 divided by 100. And that's going to give us our z-score. Now, because we're interested in the probability x less than 600, we're also going to transform that 600. And we take that 600 and we do the same thing to it. 600 minus 500 divided by 100, and if you do that out, you get 1. So the probability that x is less than 600, where x is distributed normally with mean of 500 and standard deviation of 100, that probability is the same as the probability that a z random variable is less than 1. So now we're going to be able to use our standard normal table to look up this one, the probability z less than 1, and that is going to be exactly equal to the probability that x is less than 600. Pretty cool trick. All right, so let's try it in a problem. All right, we're on slide 7 now, and we're looking at example 4. And example 4 says, a survey indicates that people use their cellular phones an average of 1.5 years before buying a new one. All right, so what do we know so far? Let's break down this problem. We've been told 1.5 years, and we've been told an average. So that sounds like either mu or x bar. And since I know that we're dealing with a problem here, basically using the normal distribution, I'm going to assume they want us to use mu equals 1.5. The standard deviation, oh, well, look at that. They're just going to tell us our sigma, and sigma equals 0.25, okay? So now I've gotten all that information. I can cross all that out. I don't need to look at it anymore. So now we have some more information. A cellular phone user is selected at random. Call that x. Find the probability that the user will use their current phone for less than 1 year. X less than 1. So it looks like what we're looking for is a probability that x is less than 1, where x is distributed normally with a mean of 1.5 and a standard deviation of 0.25. All right, so I don't need this anymore. I don't need any of that text anymore because I know what my problem is. My problem is to find the probability of x being less than 1 when x is distributed normally with a mean of 1.5 and a standard deviation of 0.25. Well, let's solve for that. So moving on to slide 8, we're going to have to do a transformation. And I'm going to show you how I like to set these up, and then we'll continue with the slide. So here we have the probability x is less than 1. That's what we need to find. Now, I like to use algebra for this, okay? So taking just that x less than 1, if I'm going to subtract the mean minus 1.5 from one side of my inequality, then I'm going to do that for both sides of my inequality. So that is equivalent to the probability that x minus 1.5 is less than 1 minus 1.5. Just going to do the same thing on both sides. Let's take that one step further. X minus 1.5 divided by 0.25 is going to be less than 1 minus 1.5 divided by 0.25. Now what I've created over here is z. That's x minus mu divided by sigma. So when I'm finding this probability, I'm going to be looking for the probability z is less than 1 minus 1.5 divided by 0.25. So that's how I like to keep track of that transformation when I am doing these types of problems. Okay, so let's move forward. There we go. X minus mu over sigma, and taking specifically for this 1 minus 1.5 over 0.25 equals negative 2. So the probability x is less than 1 is equivalent to the probability that z is less than negative 2. And that's something I can look up on my standard normal table or use statistical software to find. And I'm going to find that that probability is about 0.0228. Let's try a different problem. And again, I'm going to encourage you to pull the information out of the problem as you learn it. So a survey indicates that for each trip to the supermarket, this is slide 9, a shopper spends on an average of 45 minutes with a standard deviation of 12 minutes in the store. Ho, 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 ho. So I have mu equals 45, and I have sigma equals 12, and now I can ignore that whole first sentence. That's all the information that's in there. The length of time spent in the store is normally distributed and is represented by the variable x. Aha! So x is distributed normally with a mean of 45 and a standard deviation of 12. All right, now I can cross out this part, that sentence. A shopper enters the store. Find the probability that the shopper will be in the store for between 24 and 54 minutes. So what I'm looking for, and I've run out of room to write it, but I will try anyway. I'm looking for a probability that x is between 24 and 54. Okay. Yay! No more word problem. I know what I'm doing. I am starting with the idea that I have a random variable that is normal with a mean of 45 and a standard deviation of 12, and then I'm trying to find the probability that that random variable is between 24 and 54. Okay? All right, well, let's move forward then. So I'm going to have to do that transformation again. And this one's a little bit trickier, but I can do this. I've got 24 less than x less than 54. I'm going to run out of room here. Let me try to write a little smaller. So I'm going to subtract that mean from all three of the terms in this inequality. So 24 minus 45 is less than x minus 45 is less than 54 minus 45. Okay? Because whatever I do to one, I have to do the other. And the whole idea here is I'm trying to build z right here in the middle. So now I'm going to divide by that 12. So probability 24 minus 45 divided by 12 is less than x minus 45 divided by 12 is less than 54 minus 45 divided by 12. All right, well, I've built Z here, so that just becomes Z. 24 minus 45 is 21 over 12, I believe. Hope I got that right. And then 54 minus 45, that's going to be 9 over 12, or 3/4. Okay? 54 minus 45 is 9. 9 over 12 is the equivalent to 3/4, or 0.75. The 21 over 12, let's see, that's going to be 1 and 9/12, so that's actually going to end up being negative 1.75. Sorry, because that's a negative, right? Negative 21. Hopefully I did all that math correctly. Let's find out. Okay, let's go through. Oh, look at that. I did do that math correctly. And there we have the probability in terms of the standard normal. It's probability negative 1.75 less than Z less than 0.75, and you can either use technology or the standard normal table to figure that out. And we figure out that the probability, the cumulative probability up to 0.75 is 0.7734. Cumulative probability up to negative 1.75 is 0.0401. And we put those together, and we get that the total probability that the shopper is going to be in the store between 24 and 54 minutes is about 0.7333. This is a good place to stop, reflect on what we've learned so far, and I will see you in the next set of slides.